Hi friends, today I am going to discuss conic section from standard 11. Before I start explaining, let me share the screen. So we are going to discuss conic section. So what is a conic? A conic is defined as the path traversed by a moving point such that its distance from a fixed point and its distance from a fixed straight line. Straight line bears a constant ratio. So what do I mean by this? Now in a two-dimensional plane where we have the x-axis and the y-axis intersecting at the point O, I have a point P with coordinates x, y, which is moving. So now if the locus of this point is such that it follows certain conditions. Now what are the conditions to be followed in case of conic section? If you read, it is said its distance from a fixed point and its distance from a fixed straight line bears a constant ratio. So we have a point P which is moving, and suppose we have a point S which is fixed, and the distance between P and S must be equal to the distance of P from a fixed straight line. Suppose this is the straight line. Okay, now from this straight line, the distance of P, that is the perpendicular distance of P from this straight line. Suppose PM. If the ratio of these two lengths, that is PS by PM, is constant, then we obtain a conic section. So conic section is basically a curve. Now here we are going to deal with three different conics. The first is parabola, next ellipse, and the third one is hyperbola. So in each of these cases, this condition should be maintained. That is, the ratio between PS and PM must be constant. Now this ratio between PS and PM is termed as eccentricity. Right, and it is denoted by the alphabet small e. So if this value of E is equal to 1, we get a parabola. If the value of E is less than 1, we get an ellipse. And if this value of E is greater than 1, we get a hyperbola. So now let us learn each of these three parts separately. So what is a parabola? A parabola is a curve which is obtained by a moving point by following the condition PS by PM equals to 1. That is, the length between P and S is equal to the length of the fixed straight line from the point P. So now the different types of parabola are the different types of parabola are as follows. So let me draw the diagrams and explain each of the different types of parabola here. So I'm just dividing my screen into 4 parts to explain the 4 standard forms of parabola first of all. The first one, when we solve this equation where Px, y is a moving point, S is a fixed point having some coordinates, and we have the equation of the line PM, then we will get these forms of parabola. Y square equals to 4ax, the first case. Second case, we will get y square equals to minus 4a. Third form, x square equals to 4ay. And the fourth form, x square equals to minus 4ay. So suppose we have the x-axis and the y-axis mutually perpendicular to one another. So x, O, x dash and y, O, y dash. P is the moving point here and S is the fixed point. And P moves in such a way that it traverses this path by following the condition PS by PM equals to 1. Now we also need a fixed straight line here, and let me name this line as small l. Now this distance, that is from P to the line L, the perpendicular distance, should be equal to the distance of P from the fixed point S. Only then we get a parabola. This length must be equal to this length. So in this case, S is the fixed point. O, which is the origin, is also known as the vertex. So here the coordinates of the vertex, you can see, is the origin is 0, 0. Coordinates of the fixed point, that is S here. So here the fixed point S is called the focus. So coordinates of the focus S is a, 0, and the equation of the fixed straight line, the fixed straight line is known as the directrix. So equation of the directrix, is x equals to minus a. Now why x equals to minus a? Please try to understand. Here when P is moving, at an instant it will come to this point O. So distance of this point O from S will be equal to the distance of this point O from this fixed line, right? So this distance will become equal to this distance, and we know since the coordinates of S is given by a, 0, so distance OA, so the distance OS is a, and hence the distance of O from this point will also be a. Now as this line, that is this directrix, is parallel to the y-axis and is at a distance of a units to the left hand side of the origin, hence the equation is x equals to minus a, because we know equation of any line parallel to the y-axis is given by x equals to some constant. Here, since this line which is parallel to the y-axis is on the left side of the origin, a negative sign comes before this constant a. So equation of the directrix is x equals to minus a, or we can say x plus a equal to 0. Now, this particular parabola have several chords. Now, chords which passes through the focus are named as focal chord, and in this case, a focal chord which is perpendicular to this line where the focus lie, the focal chord will be named as the latus rectum. So, latus rectum will be of length 4a. So, what is a latus rectum here? I am naming it as capital L, L dash. You can see this is a line which is perpendicular to the axis of the parabola. Now, which is the axis of the parabola here? The line which divides the parabola into two equal halves, that is symmetrically. That particular line will be termed as the axis of the parabola. In this diagram, we can see the x-axis is the axis of the parabola, and the focal chord which is perpendicular to the axis of the parabola is termed as the latus rectum. I hope I am clear with the different terms: directrix, latus rectum, focus, vertex, right? Now, the axis of the parabola in this case is the x-axis, and its equation is y equal to 0. This is already known to us from our class 9 concept, that the equation of the x-axis is y equal to 0, equation of the y-axis is x equal to 0. So, this is all about point number 1, that is the standard equation of the parabola y square equals to 4ax. Now, when the equation of the parabola is y square equal to minus 4ax, how will the parabola look like? So, I need to again draw the x-axis and the y-axis mutually perpendicular to each other. So, this is the y-axis and this is the x-axis, right? We have P as the moving point, S as the fixed point, and the curve will turn towards the negative x-axis. I could not draw a smooth curve, it should be smooth. So, here S is the fixed point, and we also need to draw a fixed straight line. So, suppose this is the fixed straight line whose distance from the point P is this. So, we have the directrix as the fixed straight line, and PM is the perpendicular distance of the directrix from the moving point P. S is the focus here. O is the vertex of the parabola. The parabola passes through the origin O, which is the vertex, and the axis of the parabola is the x-axis. Now, you can see the directrix is on the right side of the origin, right? And the directrix is again parallel to the y-axis. So, equation of the directrix in this case, equation of the directrix is x equals to a, or x minus a equal to 0. We have the focus S. You can see S is on the negative x-axis. So, coordinates of the focus S is minus a comma 0, vertex is the origin, that is 0, 0. Moreover, the length of the latus rectum, that is L dash, will always remain as 4a. L dash is 4a, that is the length of the latus rectum. You can also see the axis of the parabola is the x-axis, that is the x-axis divides the parabola symmetrically. Now the third point, x square equals to 4ay. Let me again draw the x-axis and the y-axis mutually perpendicular to one another. So here we have x o x dash, y o y dash, and suppose S is a point, fixed point in the y-axis instead of the x-axis. Now the moving point P has to travel in such a way that it passes through the origin and it is symmetrical about the y-axis. So we also need the directrix here, which will be parallel to the x-axis now, and the distance of the point P from the fixed point S, that is the focus, is equal to the perpendicular distance of the point P from the fixed straight line here. The fixed straight line is the directrix. I am naming it as L. PM is the perpendicular distance. You can see P is a point on the curve, right? So in this case, focus is in the y-axis. So focus S is 0, a. It is in the positive y-axis. So 0, a. Equation of the directrix. Equation of the directrix is y equals to minus a, because it is a line parallel to the x-axis to the negative side of the y-axis. So y equals to minus a is the equation of the directrix. Length of the latus rectum L dash will be 4a always. Now where is L dash in the diagram? So it is a focal chord, you can see. So this is L dash. This is L dash, which is perpendicular to the axis of the parabola. Now in this third case, y-axis is the axis of the parabola. Vertex is again the origin. Vertex is again the origin here. Now the fourth case, we again need the x and y axis here. Okay, we also need a fixed straight line. By this time you know that there has to be a fixed straight line, there has to be a fixed point on the y axis, right? So the point P, suppose here, will traverse this path in this way. So this line is small l, this is the y-axis, this is the origin, this is the x-axis, right? So here also vertex is 0, 0, focus S, you can see on the negative y-axis, so 0, minus a, and latus rectum L dash has to be 4a. Equation of the directrix. Directrix is y equals to a, or y minus a equal to 0. So these are the four standard forms, and in each of these four diagrams you can see the path traversed by the moving point P always passes through the origin, and the origin is the vertex of the parabola. But it is not necessary that in every case the origin has to be the vertex of the parabola. So if the vertex is some other point other than the origin, then let us see what happens. So here we have the y-axis and the x-axis drawn. So x dash and y dash. Right. Now if the vertex is somewhere here and I name it as V, focus is here on the y-axis itself. So in that case, curve will be like this. So the parabola will look like this. So in this case, you can see the vertex is not the origin but any other point alpha comma beta, suppose. So in that case, when the curve is turning towards the positive y-axis, we can write x minus alpha whole square equals to 4a y minus beta. And if the curve faces the negative y-axis, then we can say x minus alpha whole square equals to minus 4a y minus beta. Or else if the curve faces the positive x-axis, we can write y minus beta whole square equals to 4a x minus alpha, and if it faces the negative x-axis, then y minus beta whole square equals to minus 4a into x minus alpha. So when the vertex is not the origin but any other point, I can give you another example by drawing for a parabola which is not passing through the origin, or where the vertex is not the origin. So see here another example of a parabola that looks like this. So here we have the x and y axis, and suppose the axis of the parabola is neither the x axis or the y axis, it is a line like this. So in that case, the directrix has to be the line perpendicular to the axis of the parabola in every case. So this is suppose the directrix L, and this is the axis of the parabola, and if the vertex is the point alpha comma beta here, focus is any other point here, suppose P comma Q, and the curve will look like this, which will be symmetrical about the axis of the parabola. So you can look at this diagram. This is also a parabola where the vertex is the point alpha comma beta, and the vertex is neither in the y-axis or the x-axis. Okay, so we have to keep certain things in mind while dealing with parabola. That is, the axis of the parabola divides the parabola symmetrically. The axis of the parabola and the latus rectum are always perpendicular to one another. And in case of a parabola, PS is always equal to PM. So this is the definition of parabola mathematically. PS equals to PM, where S is the fixed point called the focus and PM is the perpendicular distance of the point P from a fixed straight line, called the directrix. Right? Now, if the axis of the parabola is parallel to the x-axis, then the equation of the parabola is given by, let me write and show. When the axis of the parabola is parallel to the x-axis, then its equation is given by x equals to ay square plus by plus c, where a, b, c are constants to be determined. Now the second point here, if the axis of the parabola is parallel to the y-axis, that is when the axis of the parabola is parallel to the y-axis, then its equation is given by y equals to ax square plus bx plus c, where a, b, c are the constants to be determined. Now the parametric equations of the parabola. Parametric equations of a parabola is given by x equals to at square, y equals to 2at, where t is the parameter. Now what is a parameter here? Means the value of t will change with the change in position of the moving point. Now any moving point P will be given by the coordinates at square comma twice at. So for a different point q on the parabola, we can write at1 square comma twice at1. So this parametric form of a parabola is very important for solving certain relations. Now if P and Q are 2 points, suppose, where P have coordinates at1 square comma twice at1 and Q have coordinates at2 square comma twice at2, then the relation t1 into t2 equals to -1 wholes. So how do we get this relation? I can show you the derivation, because the derivation is quite important as it is required as a part of the answer for certain questions. So in my next video I shall show you how to derive this relation, and along with that I shall solve certain questions, important questions from this chapter dealing with parabola. So this much for today. This was a short video for just explaining what is a parabola and how it looks like. Thank you. Good day.